AOPS number theory 6.42. Find the largest integer n for which 12 to the power of n evenly divides factorial 20. So 12 to the power of n is equal to 2 to the power of 2n times 3 to the power of n. Now we're looking for the largest value of n such that these two, so 2 to the power of 2n and 3 to the power of n, are divisors of factorial 20. So we find the divisors of factorial 20. So 20 divided by 2 is equal to 10, and 10 divided by 2 is equal to 5, and 5 divided by 2 is 2.5, and 2 divided by 2 is equal to 1. So the largest power of 2 that divides factorial 20 is 2 to the power of 10 plus 5 plus 2 plus 1, which is equal to 2 to the power of 18. So then we find the largest power of 3 since it's 3n. So 20 divided by 3 is equal to 6 and 2/3, and 6 divided by 3 is equal to 2. So the largest power of 3 that divides factorial 20 is 3 to the power of 6 plus 2, which is equal to 3 to the power of 8. So, oops, let me just underline that. So then, since there are 18 powers of 2 and 8 powers of 3 in the factorial 20, we want the largest value of n that is such that 2n is less or equal to 18 and n is less or equal to 8. So if we want the greatest value that satisfies 2n is less or equal to 18 and n is less or equal to 8, and that means n must be equal to 8. AOPS number theory 6.43. There are unique integers a2, a3, a4, a5, a6, and a7 such that 5 over 7 is equal to a2 divided by factorial 2 plus a3 divided by factorial 3, so on up to a7 divided by factorial 7, where 0 is less or equal to ai, which is less than I, for when I is equal to 2, 3, ... 7. Find a2 plus a3 plus a4 plus a5 plus a6 plus a7. So first we multiply factorial 7 on both sides of this equation to get 5 times factorial 6 is equal to 7 times 6 times 5 times 4 times 3 a2 plus 7 times 6 times 5 times 4 a3, and all the way to 7a6 plus a7. So the only part that's not a multiple of 7 on the right, so by that I mean there's in this, the first term, 7 times 6 times 5 times 4 times 3 a2. It's a multiple of 7. It's also a multiple of 7 for this one, and this, and 7a6. But the only part that's not a multiple of 7 is a7. So a7 is the remainder when 5 times 6 factorial is divided by 7. Wait, this is a bit unclear. It's 5 times 6 factorial is divided by 7. So 5 times 6 factorial, since it's equal to 3,600, and 3,600 divided by 7 is 514 with a remainder of 2. That means a7 is equal to 2. So if we subtract 2 on both sides, then we get this new equation. Now it's the same thing just without the a7, and this side's 3,598. And then we divide 7 on both sides. So 514 is equal to 6 times 5 times 4 times 3 a2 plus 6 times 5 times 4 a3, so on up to 6a5 plus a6. So since all of these, just like above, all of these are a multiple of 6 except for a6. So a6 is the remainder when divided by 6. So 514 divided by 6 is 85 with the remainder of 4. So A6 is equal to 4. And then we subtract 4 on both sides to get 510 is equal to this. So the A6 is gone, and then we divide 6 on both sides. So 85 is equal to 5 times 4 times 3, A2, plus 5 times 4, A3, plus 5, A4, plus A flat 5. And we do the same thing. So since all of these are divisible by 5 except for A5, A5 is a remainder when 85 is divided by 5. So A5 is equal to 0 since the remainder is 0. So then we divide 5 on both sides without the A5. So 17 is equal to 4 times 3, A2, plus 4, A3, plus A4. And since all of these are multiples of 4 except for A4, A4 is the remainder when 17 is divided by 4. So A4 is equal to 1. And so then we subtract 1 on both sides to get 16 is equal to 4 times 3, A2, plus 4, A3. And then we divide 4 to get 4 is equal to 3, A2, plus A3. And then if we just solve this, A2 is equal to A3, which is equal to 1. So the sum of all of these is equal to 9.